Okay, welcome to 2.1. We're looking at similar polygons where we're solving for a certain side. So there's a lot here. This is 2 pages of notes just to start with. So first thing you need to know, similar polygons. So I'm going to read this in math terms. In the diagram below, triangle ABC, that's right here. Triangle ABC is similar to triangle DEF. So when we write that, how I just read it, ABC is similar to DEF, we use this squiggly line. So this means similar. When you see that, you read it as similar. And a similar transformation is what we were just doing. It's a dilation. Okay, the angles are equal. And the sides have all changed by the same scale factor. So what we just did, we dilated stuff. We were making similar images. So the big difference here is our side lengths are proportional. And what I mean by that is I have triangle RST is similar to XYZ. It's saying find the scale factor. So you see which sides align. These sides align, and we want to find the scale factor from RST to XYZ. So the scale factor we say is the new length, the dilated over the old. So I would take 15 over 25, and that's my scale factor. Reduced would be 3/5. And I can do that with every side. So how about we go 18 and 30, new over old. Guess what I get? 3/5. And then the last one, 12 over 20, new over old. 3/5. So the scale factor is the same for all sides. It's a dilation. Okay, list all pairs of congruent angles and write the ratios of the corresponding side lengths in a statement of proportionality. So I'm kind of running out of room for that. But all congruent angles the angles stay the same. So T is congruent to Z. R is congruent to X. S is congruent to Y. Okay, remember the angles don't change, it's just the sides. So a statement of proportionality would mean what we did here. ZX divided by TR equals, and then I would do all the sides. YZ is equal to ST. I'm running out of room. I'm going to come over here. And then I would do the last side. XY. And then RS. So those are all the sides. It's what we just did over here in Desmos divided. Those all equal 3/5. So we use that to find values. So here we have triangle DEF is similar to MNP, and we want to find the value of X. So if these triangles are similar, the scale factor for each one's going to be the same. So these sides are aligned. If I take 15 to 18, it doesn't tell me which way to go here. That ratio is going to equal the same as X to 30. And it's also going to equal 20 to 24, but we don't need to use that, right? You only need 2 ratios to solve. So first thing, I'm going to reduce this fraction. So 15 over 18 reduces to 5/6. And then we do this thing called cross multiply. When you have a fraction equal to another fraction, you take 5 times 30, which is 150, and then you set it equal to the other side, 6 times x, which is just 6x. And then you can solve as normal. So that gets rid of the fractions. So divide both sides by 6. 150 divided by 6 is 25. That would be my value. So this number is 25. Okay, that's the first page. The second page goes into perimeter and area. So if two polygons are similar, their perimeters is equal to the ratios of their side lengths. So if I take the perimeter of one shape, a perimeter of another shape, so perimeter of 1, perimeter of 2, that equals that side ratio, the scale factor. And area is similar. If I take the area of one and divide it by the area of the other, it still equals that side ratio, but the difference here is area is a square unit, sides are not. So we have to square the side ratio in order to make our units the same. So here's a little example. We have triangle ABC is similar to DEF. Find the area of DEF. I'm going to call that our X. Okay, so remember the area of one triangle. So let's do area of ABC to the area of DEF is going to equal the side length of ABC over the side length of DEF, but it's squared. So the area here is 36. We're trying to find that area equals 10 to 5. Those are our side lengths squared. Okay, 36 over x, and then I'm just going to put that in my calculator. 10 divided by 5 squared is 4. And just because it's easier to solve fractions, what if we leave it as 4 over 1 and then cross multiply? 4 times x equals 1 times 36. How do we solve for x? Divide both sides by 4, x equals 9. And that's it for this section. So we're using ratios and similar polygons to solve for stuff.